So, guys, thank you so much for joining. I welcome you all to the first and the introductory classes. I welcome you all to Faujis Academy and Willy. Faujis Academy is the written wing of Willy, wherein we prepare for this defense services examination. Okay, and I'm the lead mentor over here, and I'll be teaching you guys mathematics. Right. So, those of you know me, Abhikaran, Muilan, Mateshwaran, and all, they will know me already, and they have been associated with me since AFCAT times itself. And those of you do not know me, I'll drop a little bit of introduction of myself. So my name is Gaurav Snehil, and I actually belong to the state of Bihar. That's where my hometown is, in a small district called Khagadia. Okay. As per the Niti Ayoga report, it is one of the most backward districts across the nation, both in terms of economy and literacy. But it's a very promising district, and I was fortunate enough to study in your state, in the state of Tamil Nadu, and that too in Sainik School Amaravathinagar. And post my Sainik School journey, I went on to pursue my graduation in philosophy from Banaras Hindu University. I pursued my education in philosophy. I studied Western philosophy, Indian philosophy, and the likes of it. And post that, I went on to pursue my MBA from Indian Institute of Management, IIM Kozhikode, right? And for that, I had to crack an examination called CAT, and I had over 97 percentile in quantitative aptitude. And there was another examination I appeared for that is called what that is called problem solving assessment, okay, conducted by CBSE, and in that I had in quantitative aptitude 99.41 percentile across the nation. Okay. So with this with these credentials, really thought to me, really called upon me as to help you guys in prepare for your examinations, your CDS, AFCAT, CAPF examinations, and more specifically mathematics as a subject. Okay, so I'll be helping you guys in that front. So before I start talking more about it, I'm getting a call from my mother, so just give me one moment. Guys, there was a cross call. Sorry about that. Okay. So before I get on to your, you know, mathematics and more specifically number system, just wanted to tell you that I don't know how many times I've appeared for CDS, and I have got it. Hello, हाँ मम्मी प्रणाम. क्लास कर रहे तो बाद में बात कर. Class, and I do not remember how many times I've appeared for AFCAT as well. It must have been close to 7 times, and I have cleared all the times I've appeared for it, and I have appeared for NDA for 5 times, and I have cleared 4 times out of it. Okay. So with this credential, Willie chose me to help you guys in your examination pursuit. Wanted to get you a clear figure, clear picture in your mind, right? Before we start delving into your mathematics, that in your CDS paper, there will be 100 questions, okay? 2 hours of paper. Let's just reduce it to 1.5 hours, okay? 1.5 hours. Why? Because you'll be having attendance sheet, and also you'll be bubbling your answer sheet as well, your OMR sheet as well. So 1.5 hours of effective time, and you will be shooting for 100 questions and 100 marks. Okay, if you are able to get 35 to 40 marks, okay, this is considered as good. Okay, if you are able to get 45, 40 to 45, this is considered very good. Okay, and if you are getting anything above 45, it is considered as excellent, right? Why? Because I'm telling, there will be 3 papers. All of you will be appearing for 3 papers. Okay, English, your GKGS, and your mathematics, right? So in English, you should try and get somewhere close to 70 marks. This is what you should be pushing for. And in GS, you should get anywhere between 30 to 40 marks out of 100, I'm saying. And in mathematics, again, you should push for somewhere around 40 to 50 marks. Okay. So anything like let's keep it as 35 and let's keep it as 45 if that is the rough average number. So with this you will be reaching 150 and you will be comfortably clearing all the cutoffs. Okay, if you push yourself a little bit more harder, you will be getting 155 and all, and you will be easily clearing the IAF cutoff as well. Right, ladies and gentlemen? Right, gentlemen alone, not ladies. We won't have ladies with us over here. And as far as mathematics is concerned, we won't have ladies with us. We'll only be dealing with the gentlemen, right? So stick with me, all 8 of you, through the end of the, our affairs with mathematics as a subject. And I promise you that you will be feeling very much confident in appearing for your examinations. Right, ladies and gentlemen? Right, gentlemen, sorry. Yeah.
Yes, sir.
Am I clear, gentlemen? Yeah. Stick with me throughout. Okay. All 8 of you just stick with me throughout the paper, throughout the classes. What we are going to do, the modus operandi will be for each of the chapter. Day 1 we'll only talk about concepts. Okay. Day 2 we'll only talk about questions. Okay. And day 3 we'll only talk about PYQs. Okay. So each of the chapters I'll be taking at least 3 to 4 classes. Okay, anywhere between 2 to 4 classes. Let's say chapter is small, I can finish it off in 2 days also. And let's say if the chapter is long, I will take 4 classes as well. Okay, I have shared the Pathfinder PDF to you. That will be basically the source from where I'll be taking the questions. Okay, and I'll be solving the select questions. So if you have got the PDF with you, okay, if you have got the PDF with you, can you see my screen? Can you see my screen, guys? Okay, so this is your number system. Is my screen visible? This is your number system, and there is like 120 question. Can anyone confirm if my screen is visible? Guys, is my screen?
Yes, sir.
Yeah. So open that soft copy, and there's like 120 questions in the next 3 to 4 days. Okay, we'll just try to finish off these 120 questions. It's not possible for me to finish off all the 120 questions, so you will have to do it at your own end, and if you have any doubt, just bring it to me, right? Okay, so today the agenda for today is to understand what number system is. So sit back and relax, and let's just get started. Okay, so number system as a chapter will have like close to 30 chapters in your entire mathematics paper. Okay, and out of those 30 chapters, you will be having 100 questions, right, in a serious examination. So number system specifically has 10 to 12 questions, right? And 10 to 12 questions are very, very huge marks. Okay. So even if you are able to get like 6 to 7 of them correct, you are good to go. Okay. So without any further ado, let's get started. In number system, it's all about numbers. Okay. So number system, the very first and the foremost thing I wanted to talk about the decimal number system. The computer engineers out there, you must be dealing with binary 0 and 1. Okay, these are called binary. Okay, binary digits. Okay, and over here it is decimal number system, and this decimal number system, we leverage this 10 characters from 0 to 9 to represent digits, right? Right. So I'm sure you guys are understanding. So the first and foremost thing is the natural numbers. What used to happen in the old times, I talked about this to AFCAT guys as well, that in old times, what used to do, that the shepherd out there, they used to count their sheep and cattles, right? So for that, they used to use few of the pebbles and stones. Okay, like how many stones, how many pebbles I have? I have 6 stones. That means I have 6 sheeps. Okay, I have 5 stones, so I have like 5 cows. Okay, so this is how they used to leverage these numbers, and that's the basic genesis of your natural number. Counting numbers are called your natural numbers. So what are the counting numbers? Can you count it as something as 0, or can you count something as -1? The answer to this question is no. You can only count numbers as 1, 2, 3, 4, 5, 6, and dot dot dot. Okay, up till infinity. One question to you all: what is the biggest possible natural number? What is the biggest possible natural number? Joshua, over to you. What do you think about this?
Sir, I think it will be undefined because
Yes.
there are infinity numbers are there, so we cannot define it. What
Yes.
it up to.
Absolutely, absolutely, Joshua. Thank you so much. Thank you so much. So we cannot really define which one is the highest natural number, right? Because it can extend up till infinity. Okay, let us say I'm writing some number one. Let us say 1, 2, 5, 6, 7, 8, 8, 9, 7, 2, 4, 3, 1, 8, 7, 6, 5, 1, 2, 0, 9. 93748. You just keep on writing, it just never ends, right? So there is no upper limit to what is the biggest natural number. We cannot find it, and that's why it is undefined, or in other words, this is also called what? Infinity. Right, ladies and gentlemen, right, gentlemen. So natural number is your counting numbers 1, 2, 3, 4, 5, 6, 7, 8, and things like that. Whole number, just include 0 into it, you will get the whole numbers, right? And what do we mean by even numbers? Everyone knows it, the number which is divisible by 2. Okay, 6, 8, 10, 12. Is 0 an even number? Yes, 0 is also an even number, right? Odd numbers 1, 3, 5, 7, 9, 11, and things like that. And what are prime numbers? What are prime numbers? A number which has got only two factors, okay, only two factors, those numbers are called your prime numbers, right? So let us say, for example, let's take the number 17. So in 17, what are the factors of 17? I mean, what are the numbers which actually divides 17 completely? What are those numbers? What are those numbers, guys?
1 and 17, sir.
1 and 17 only, that's it. So it has only two factors, that is 1 and 17. Right, Avikaran, are you following me?
Yes, sir, I'm following you.
Cool. Thank you so much. And we had a participant, and that participant has run away for some reason, maybe some network issues. No worries. Okay. So prime numbers are your 1 and 17. Over here, it has only two factors. Okay. Any number which will have more than 2 plus factors, that will be called what? Your composite number, right? And in from prime number itself, there will be co-prime numbers. Okay. What will be the co-prime numbers? Okay, let us say I'm saying some number called 5 and 17, right? So the HCF of these two numbers, if it becomes HCF is equal to 1, okay, highest common factor. I'm assuming that you all know what is highest common factor, right? So if the highest common factor HCF is 1, those sort of numbers will be called co-prime numbers, right? But over here you will see that the difference between 5 and 17 is 12, right? If the difference of these two are also a co-prime number, right? Because the HCF is 1, but what we observe that their difference is only 2. Okay, let us say 3 and 5, 5 and 7, 11 and 13. These are called your twin prime numbers. These are called what? Twin prime numbers, right, guys? So I hope you are clear with natural number, whole number, even number, odd number, prime number, co-prime number, twin prime number, and composite number. Anybody, any doubt? And before I move on, just wanted to ask, can we represent every even number in the form of 2n, where n is a natural number, or whole number? Yes or no? If you put the n is equal to whole number, if n is equal to 0, what will be the value of this? It will become 0. If n is equal to 1, this value will become 2. If n is equal to 2, this value will become 4. Right? So these are all Even number can be represented in the form of 2n, and odd numbers can be represented in the form of 2n plus or minus 1. Okay, right? Yes, anybody any doubt? Yes, Divakar, can you please speak up? Yes, I can. Of course, I can explain it to you for sure, but I want you to speak up, Divakar. Yeah. How are you doing today? All good, Divakar? Is your mic working, buddy? Divakar, am I audible to you? Yes, Divakar, am I audible to you, buddy? Speak up, guys. Speak up. Divakar, let's speak up. You got to speak in your SSB, you will have to open your mouth and speak. Yes, Divakar, you have unmuted yourself. Yeah, say something. All good, Divakar? You understand English? Divakar? Okay, no problem. Look, Divakar. So co-prime numbers are the numbers in such a way that their HCF, okay, highest common factor is 1. Okay. So let us say, for example, number 13 and 15. Okay. If we find out the HCF of these two numbers, what is the HCF of these two numbers? 1. In co-prime number, is it mandatory that each of the individual number has to be a prime number? The answer to this question is no. 15 is not your prime number, but 13 and 15 mutually would be considered as what? Co-prime numbers, right? Right? And Divakar, is it clear to you? I don't know what's happening. Yeah. So, and the twin prime numbers, the such type of co-prime numbers wherein the difference of these two numbers is only 2, right? Like 3 and 5, 5 and 7. In that case, you will be having what? You will be having these two pairs of numbers are called twin prime numbers. Twin prime numbers. Okay. Divakar, is it clear to you? Divakar, is it clear? Divakar, is it clear, buddy? You got to move. Okay. Yes. Thank you so much. And for some reason, I don't know what has happened to Senthil Raja Shivakumar. Anyway, yeah. So moving on, we have something called integers. Okay. Integers, all your whole numbers. Okay. Up till infinity, just extend it to the negative side of it. Okay. Up till infinity. Right. So your positive integers, these are all your positive integers. Okay. Non-negative integers. Okay, over here it is negative integers. Let's just try to understand negative integers. Okay, so all the numbers from -1 to infinity are your called what? Negative integers, right? Now tell me whether 0. Okay, my question is 0 a non-negative integer? Yes, Abhikaran, answer. What do you think about it? No, I'm asking the answer to this question is either yes or no. I wanted an answer from you. Is 0 a non-negative integer? Yes, Joshua.
No,
What do
sir,
you
I think.
Okay. Yes, Joshua, what do you think about this? Dinesh, what do you think about this?
I think 0 is a non-negative integer.
Yes, that's correct. Okay. It's a non-negative. Negative are what? Negative are these ones, Avikaran? Okay. When we say non-negative, just chuck it out. That's it. So all rest of it, including 0, will be your non-negative. Okay. Including 0 will be your non-negative integer. Clear, Avikaran?
Yes, sir, I understand, sir.
Cool. So integers done, positive integers done, negative integers done, non-negative integers done. Rational numbers are the numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Everybody knows it. You all know it. So rational number, if I have to tell you, other than that also, any fraction, okay, any fraction which is non-terminating but recurring means repeating. Let us say I say 0.3 bar. It's non-terminating number which is equivalent to 0.333 3, 3, 3, 3, 3, 3, 3. Just keep. This is a rational number, right? This is a rational number. In other words, 22 by 7 also an example. 22 by 7 is another prime number, sorry, rational number. Okay. Why? Because it is in the form of P by Q. Your P is your numerator, your Q is your denominator, and Q is not equal to 0. But the corresponding to it pi is not your rational number. Okay. It's not your rational number. Pi is your irrational number. Right, guys? Okay. So rational numbers, all the numbers which can be expressed in the form of P by Q, where P and Q are the integers. Okay, integers. Just now we studied what are integers. Okay, and Q is not equal to 0. What happens if Q equals to 0? What happens if Q is equal to 0? Tell me. What will be the value of 3 by 0? Any guess?
Infinity, sir.
Infinity. Absolutely. Okay. The whole point of writing it in the form of P by Q gets defeated. Right? Yes, Divakar, I got you. But from next classes onwards, I want to hear your voice. Right? So irrational number, apart from that, this is completely undefined, or in other words, infinity also we tell it, right? So irrational numbers are all of your root numbers, root 5, which are not, complete square roots. Okay, root 3. Can you say root 4 as a rational or irrational number? Root 4 can also be written in terms of 2. Okay, root 4, root 9. These are all your perfect squares. Okay, even though this is in root 16, even though this is in root, it doesn't mean that it's a prime number. It's a irrational number. Only if the value that is there inside the square root, if it is not a complete square, then only it will be a rational number. Right, guys? Okay. So whatever type of numbers that we studied till now is called what? Your real numbers. Okay. Whatever kind of numbers that we have studied till now is called your real numbers. Let me explain it to you with an illustration. Okay. So what are natural numbers? 1, 2, 3, 4, 5. All these counting numbers are your natural numbers. Plus 0, it will become whole numbers. Okay. Plus -1, -2, -3 to the left hand side, it becomes integers. Okay. Plus all the fractions, plus decimals. Decimal and fraction both are almost the same. You will get the rational numbers, and just the opposite of it, which cannot precisely. Now you will tell me, sir, root 2 is 1.414. Yes, it is, but this is not the exact value of it. Right, this is not the exact value of it. So that's the problem, that these roots are also considered as what? Irrational number. Okay. So the collection of all of these, natural, whole, integers, rational, irrational, prime, composite, even, odd, this, that, is called what? Your real numbers. Okay. In simple terms, real numbers are the numbers which can be expressed, on the number line. Okay, number line looks like something like this: 0, 1, 2, 3, like that. Okay, and what if I tell you draw root 2? Okay, so root 2 is 1.414. It's somewhere here, like this. I hope my screen is visible. My annotations are visible. It's somewhere here. Yeah, this is 1.4, right? So root 2, how do people find it out? Root 2, first there is value as 1. Okay, and then people will draw something like this, just 1 over here. Okay, and this value is your root 2. Then they will take this distance, and from here they will draw an arc, and this arc will fall somewhere over here, right? I hope you guys know it, and if you don't know it, it's okay. It's not that important. Okay, how and why to draw it on the number line, that will not be asked in your question paper. Okay, but just for the knowledge, I wanted you guys to know. Shall we move? Shall we move, guys?
Yes, sir.
So far clear, Mateshwaran, Muilan, Sivakumar. So far clear with you all. Joshua, Diwakar, Abhikaran. So far, are you guys with me?
Yes, sir.
Cool. So the real numbers. Okay, real numbers. Okay, forget what is this real number. Okay, this heading, just forget it. Okay, it's not required. Just focus on this. If x is any real number, or if x is any number, let's read it that way, then mod of x is equal to x when x is greater than 0. Okay, let us say I said x is equal to 5. Okay, so what happens? Mod of 5, that means mod of x is equal to 5 only, right? Right now, the second case is 0 when x is equal to 0. I said x is equal to 0. So mod x is equal to x, wherein x is what? Your 0. Mod is equal to 0. I mean 0 is equal to 0. That's it. There's nothing for us to understand over here. But this case, I want you guys to pay attention. Okay. So mod of x is equal to minus x if x is less than 0. So let x is equal to minus 20. Let. This is our assumption. So that means we'll be dealing with this case, third one, x is less than 0. X is less than 0. So mod of x is equal to x. Okay. Mod of x is equal to x or minus x when x is less than 0. Why? Because mod यहाँ पे over here we have assumed x is equal to minus 20, which is less than 0. That means what? Mod of minus 20 is equal to minus of minus 20, right? 2 times minus. And what have we understood? What have we known? If it is in multiplication, 2 signs plus plus will give us plus. Plus minus will eventually give us minus. Minus plus will give us minus. And minus minus will eventually give us minus. Right? So 2 times it is minus minus, that is plus, which will eventually give us 20. Right? And that is why we say mod of x is equal to minus of x when x is your less than 0. Right? Because this value of x itself is 20. You know, now when you say, no, everybody says, no, anything coming out of mod will be positive. Right? This is what we know. This is what every one of us have understood. Right? Isn't it? Say yes or no.
Yes, sir.
Yes or no? So how has it become positive? This is what I'm trying to tell you. If x is equal to minus 20, so in order to this minus 20 to become positive, it has to be multiplied by another minus sign in order to get positive, right? In order to make this number 20 as positive, right? So this number will eventually become your 20. Okay. And this is what we say, anything coming out of mod will be positive. This is what we say. Right. So this is the basic logic. This is the basic reasoning behind it. Right, gentlemen? So far, are you with me?
Yes, sir.
Cool. Just sit back, relax, and enjoy the show. From tomorrow, we'll start solving the questions and then we'll have a lot more fun. So concept of unit digit. Okay. Concept of unit digit. Before I start telling you what is the concept of unit digit, I want you guys to help me fill up this 4, 5, 6, 7, 8, and 9. So let us say this number over here is A. Okay. And over here is A raised to the power something. A square, A cube, and A4. Right? So if you do it something like this, what do you find? It's 1, it's 1, it's 1 only. 1 only, right? 2, 4, 8, 16. 9, 27, 81. How much is this? 256, 625, 36, 216. How much is that? Some number ending with 6, right? Some number ending with 6. Let's know that. 49, 343. Some number ending with 1. 64. Some number, okay, 512. Some number ending with 6. 81, 729, and some number ending with 1. Right. Now just write down only the unit digit of all of this. 1, 2, 3, 4, 5, 6, 7, 8. You will have at least 1 or 2 questions from unit digit. Know it, learn it. This is the unit digit. 2, 4, 8, 6, 3, 9, 7, 1, 6, 4, 6, 5, 5, 5, 6, 6, 6, 9, 3, 1, 4, 2, 6, 1, 9, 1. Right. This is the unit digit. This is the unit digit, guys.
Yes, sir.
Yes or no? Yes or no? Are you guys enjoying these numbers? These are all really funny. Okay, very, very interesting ones. If I have to tell you a raised to the power 5, what will be the unit digit over here? Only 1. Okay. Now 6 into 2, 12. That means 2, right? Now 3 into 3, 3 into 1, 3, 4 into 6, 4, 5 into 5, again 5, 6 into 6, 6, 7 into 1, 7, 8, 9, right? What do you see over here? This and this are all the same. It's all the same. Anybody up till now who has not followed me, please ask. Mateshwar and Muilan, it's all the same. What point I'm trying to drive over here is that any number, specifically the unit digit of any number, will have a at max cycle of 4. After 4, it will start to repeat. Okay. In case of number digit 1, this cycle is only 1. Only after every single digit, every single unit digit is being repeated, right? For number 2, it is getting repeated after 4 numbers. For 3 also, after 4 numbers, the cycle is 4. For number 4, this particular number 4, what is the cycle? What is the cycle
2,
for
sir.
unit digit? 2, absolutely. For 5, what is the cycle?
1.
1, yeah. For 6, what is the cycle? 1. For 7, what is the cycle? Again, 4. And for 8, what is the cycle? Your 4. And for 9, the cycle is 2. Right. So if I ever have to ask you, let me ask you a question over here. In fact, 2 questions. I want all of you to do it. Okay. Let us say I gave you some number. Yes. Find out what is the unit digit and tell me. What is the unit digit, guys? Yes, boys. Be quick. Be quick. I've told you what is the cycle. So whenever we have to find the unit digit, first of all, what we do is that we only deal with unit digit. That's it. We'll forget all the numbers. Just forget all the numbers. Write it down. Now, do the multiplication. 9 into 1, 9. 7 into 4, 28. And 8. Again, just forget the other numbers except the unit digits. 8 into 8, 64. Into 9. Again, forget all the other numbers except the unit digit. So 9 into 4, 36. And what did I ask you? Unit digit. What is the answer, guys? What is the answer, guys?
6, sir.
Absolutely, that's correct. Yes, Shivakumar, what do you think is the answer? Damn plus 1 marks Bari from this unit digit concept alone. Avikaran, am I audible? Am I audible, Bari? Avikaran?
Yes, sir. Yes, sir. You are audible, sir.
Yes, what is the unit digit?
For this sum, sir.
Yes.
6, sir.
Okay, cool. Now, if I ask you in the same question, what if I do another thing? The another thing is that I replace all of this multiplication sign with plus sign. This question will be answered by Mateshwaran. Mateshwaran, are you there?
So yes,
So what is the unit digit over here? If we replace all the multiplication sign with a plus sign, what will be the unit digit over here? So the first step, Mateshwaran, look,
yes, sir.
to solve this type of question is to, when we are dealing with unit digit, we'll forget all the rest of the digits. Forget all the rest of the digits for any operator. What is the unit digit over here? 9 plus 1, right? Plus, what number is this? 4
4.
plus 7
Seven.
plus 8. What is this?
Sir, 29, sir.
29. Okay. So what is the unit digit?
29.
Unit digit. Unit digit.
Sir, 9, sir.
9. So the answer to this question will be your 9. That's
Yes,
it.
sir.
Okay.
Yes, sir.
Got it?
Got it, sir.
Yeah. Unit digit means only deal with unit digits. Rest of the number just toss it away. Okay. Now this question is for Avikaran. What is the unit digit?
So
Sorry?
I will tell the answer, sir.
Yes. Take your time and tell the answer. It's for others as well. Isn't this mathematics interesting? Joshua, what do you think about this, buddy? Joshua,
Yes, sir.
what do you think about this question? 9 raised to the power 99926. What is the unit digit? You only have two options. It will be either 1 or 9, right? There can't
Yes,
be
sir.
any
Yes,
other
sir.
number.
Yes, sir.
Which one of these two number is the answer? Tell me.
9.
Yes, that's correct. What is the unit digit here?
Here is 9 power 2 answer and
9 power.
huh?
Avikaran, what is?
9 power 2 answer. I think it will get 1, sir.
You are saying 1. Okay.
Yeah, unit.
Joshua is saying 9. Okay. So look, the cyclicity of 9 is what? 2. Cyclicity is 2, right? That means 9 square 81, 729. Okay. At 1, 9 raised to the power 1, 9 raised to the power 2, 9 raised to the power 3. Okay. And over here 9 raised to the power 4. Right. So again, some number will come with 1. Okay. So at the even places, what do we see? The unit digit is 1. Yes, Avikaran, you are right. You are right, Avikaran. Okay. So since this is an even number, 2, 6, this is an even number. Okay. So that means it's damn sure that it will have its unit digit as 1 and not 9. Sorry, Joshua. 1 is the answer over here. Yes, Joshua and Abhikaran, both of you, tell me, what is the unit digit over here? Without picking pen and paper, tell me. Tell me the correct answer, both of you.
9, sir.
Yes, absolutely. Because had it been even, had this number been even, we know it is ending with 1. If it is odd, we know it is ending with 9. Right, Avikaran? Thank you so
Yes,
much.
sir.
Unit digit, is it clear to all of you?
Yes, sir.
And what if I say you 120, okay, like this? What is the unit digit? What is the unit digit? Think about it and tell me. Okay, tell me what is the unit digit in 5 factorial? That is 120 factorial, I said. Tell me what is the unit digit in 5 factorial? Yes, boys, is it that tough?
Sir, which one?
Either 5 factorial or 120 factorial. The answer will be same. 5 factorial means what? 1 into 2 into 3 into 4 into 5, right? Right, no? So if you do it, you see that if 5 into 2 is 10, so obviously there will be 0, which will be a unit digit, right? So if you have to do 1 into 2 into 3 into 4 into 5 into 6 into up till 120, there is damn sure that so many number of zeros coming in or not?
Yes, sir.
So what will be the unit digit?
0.
0. Obviously, 0 will be a unit digit. That's it. Okay. Mathematics is interesting.
Sir, then factorial above 5 always have that 0 digit.
Yes.
Yes.
Yes. Yes. That's correct. Factorial above 5 will always have its unit digit as 0. That's correct. Cool. Anybody who did not get me? Anybody who did not understand anything? Please shoot your questions. Otherwise, I'll move. Unit digit, you should expect some 1 or 2 questions in your examination. So this is damn important. We'll do different types of sums tomorrow. Shall we move, guys?
Yes, sir.
Cool. So over here, the first thing about the division of the numbers, we wanted to study the divisibility rule over here. Okay. So the first concept over here is dividend is equal to divisor into quotient plus remainder. Right. So let us say we have some number. Let us say we have some number 792. Okay. And this number is being divided, let us say, by 5. So how will you divide it? 1 time 2, 9, 5 times 25, 4, 2. Basically, it is saying dividend. Dividend is this. 729 is equal to divisor. Divisor is this. Into quotient is this much, 158. Plus remainder is how much? Your 2. Now, let's do we get this number? Do we get this number, guys? Did we do some
Yes, sir.
mistake? Do we get this number 792.1529 54242? Do we get this number? Like seriously, where did we make
Yes,
the
sir.
mistake?
We
Yeah.
we have getting the numbers, sir.
Yeah, it's
790.
790. Okay. So this is what we mean by this particular expression over here. Okay. In Hindi, we call it bhaji is equal to bhajak. I don't know, I forgot that. Okay, let it be. So dividend is equal to your divisor into quotient plus remainder. Right? Remember this property. It will be very much helpful. Right? So let's move. I'll move very quickly over here. I know every one of you already know it. What are the divisibility rules? So I'll let you know any number, any even number will be divisible by 2. Okay. Let's say any number 1, 2, 3, 5, 6. If the unit digit is an even number, it will be divisible by 2. Is 0 an even number? Yes or no? Is 0 an even number? Guys, is 0 an even number? Yes. 0 is an even number. So 1 is prime or composite? Just asking.
Prime.
1 is neither prime nor composite. Okay? Remember it. 1 is neither prime nor composite. Okay? Now let's go ahead with what is the divisibility rule for 3. If a number, let us say number we have is 1, 3, 2, 6, 4, 2. Okay. If the sum of the numbers, what is the sum of the numbers here? Quick guys, what is the sum of the numbers here?
18, sir.
If the sum of the number is divisible by 3, this number will also be divisible by 3. Right? Cool. Let us say we have some number called 1, 2, 8, 6, 9 and and something called 88. Okay. Tell me, is this number divisible by 4?
Yes, sir.
Yes. Absolutely. So the divisibility rule for 4 is the last 2 digit has to be divisible by 4. That's it, is your rule. For 5, the unit digit has to be what? Either 0 or 5. Clear? Clear. I'm assuming that you guys know this much. This is my assumption. Anybody who did not get it, please raise your hand. So for divisibility rule for 6, if a number is divisible by both 2 and 3, let us take just a small number 12. Okay. Is this number divisible by both 2 and 3? Yes. And that is why it is divisible by your 6 as well. Let us take a number 21. It is divisible by 3 but not 2. So is it divisible by 6? No. Right? So what are the numbers which is divisible by both 2 and 3? It is 6, 12, 18, 24, 30, 36, 42, 48, and all, right? Which is basically nothing but your multiples of 6, right guys? Right? Shall we move to the divisibility rule for 7? Who will tell me what is the divisibility rule for 7? Any one of you. Any one of you. What is the divisibility rule for 7?
Sir, I think the last digit has to be multiplied by 2 and subtracted to the remaining number.
Yeah, that's correct. Yeah. So divisibility rule for 7 is very dicey. Okay. What are the numbers, let's say, divisible by 7? Let's say 35. Okay. Let's say 56. So the last digit has to be multiplied by 2. Last digit multiplied by 2 means 10, and then subtracted by the remaining number. Okay. Last digit is multiplied by 2, 6, 12, and then remaining digit. So minus 7 or minus 7. Okay. Or in other words, let us say, let's take some number which is, let's take this number called, so let's take this number 238. I have calculated that this number is divisible by 7. Okay. So how you will be calculating this? 8, 23, just write it down, minus 8 into 216. If this number is divisible by 7, then we'll conclude that this whole particular number is divisible by 7. Okay. So let us say some big number. Let us take some big number. Let us take some big number over here. And that number is 691292. Okay. Now you have to tell me, is it divisible by 7? Okay. So first you will write down this. See, divisibility rule for 7. Okay. It's as good as not knowing it. But just for the sake of information, we are learning it. How much is that? 69125. This is iteration 1. Again, we'll do the same iteration. Okay. 6912 minus unit digit into 2. How much is that? 6902. Again, we'll do another one. 690 minus 2 into 2. 4. How much is that? 686. Right? Let me know if I make any mistake. So 68 minus 12. How much is that? 56. Is it divisible by 7? Yes, it is divisible by 7. So we'll conclude that this number is indeed divisible by 7. Right, boys? Now you will ask me, sir, rather than doing all these steps, why could not have I simply tried to divide this number by 7 and found out the answer? Yes, you could have done that, right? Now divisibility rule for number 8. What is the divisibility rule for number 8? What it is, guys? Last 3 numbers, last 3 digits of a particular number. Let us say 967. 82, and how much is that? Let me say 816. Is it divisible by 8? Is this whole number? So in order to find out, we'll have to pick up last 3 digits, that is 816. Is it divisible by 8? Yes. Yes, it is divisible by 8. And that's how we'll conclude that this number is also divisible by 8. Or otherwise, if these 3 numbers are 0, in that case also we'll conclude that that particular number is divisible by 8. Right, boys? Shall we move? Who will tell me what is the divisibility rule for 9? Divisibility rule for 9 comes into the picture from the divisibility rule for 3. And what did we learn from the divisibility rule for 3? If A, B, C, D, E, F is a number, so A plus B plus C plus D plus E plus F, if it is divisible by 9, this particular whole number will be divisible by 9. Right? Right, guys? Am I clear, guys? Do you have any doubt? Any question? Any query? Any concern? Shoot up, shoot up. Shall we move? So for the divisibility rule for 10, everybody knows that the unit digit has to be invariably 0. Right? Right, Muilan? Right, Mateshwaran? Is there anything you did not get it? Shivakumar, anything you guys did not get it? Okay. Now let's move to the divisibility rule for 11. Okay. Let us say there is some number. Okay. Let us say the number is 2, 2, 2, 2, 2, 3, 3, 3, 3. Is this number divisible by 11? Yes or no? Is this number divisible by 11? So the rule says that if the difference between the sum of the numbers which is present at the alternative places is either 0 or divisible by 11, in that case, that particular number is divisible by 11. Okay. So what are the numbers at alternate places? 1, 2, 3, 4, 5. Okay. 3, 3, 6, 6, 6, 12. Minus 3, 3, 6, 2, 2, 2, 12. What is this? It's either 0 or divisible by 11. Right, guys. So let us say, let me take some random number. Okay. And that random number is, a moment, guys. Let us say this number is, yeah. Tell me, is it divisible by 11 or not? Yes or no? Is it divisible by 11, guys? Quick, let's take the alternate numbers. This is 6, 4, 0. That means 0 plus 6 plus 4. That means your 14. Over here it is 8, 1 and 1. Right? 6, 4, 0. 8, 1 and 1. Okay. So is it divisible, guys? Yes, guys. Is it divisible? 1, 0, 8, 4, 1, 6. Okay. 6, 4, 10. Why am I writing 14? It's 10, guys. And over here also 8, 1 and 1. That means also 1 plus 8 plus 1 is equal to 10. Right? So what is the difference of these two? It's 0. That means what? It is divisible by 11. Right? Anybody who did not get it? Any one of you who did not get it? Guys, shall we move? Divisibility rules. Is it clear to you? Is it clear to you, guys?
Yes, sir. Understood, sir.
Yes. Anyone who did not understand? Joshua, Shivakumar, Moilan, Mateshwaran, anybody, any one of you? I say either yes or no. Okay, Joshua, thank you so much. But you guys need to open your mouth, right? This is what the house rules are. So there are the few of the identities. Okay. To understand these identities, these are your formulas. So go back your home, remember this formula at your own end. What we'll be doing over here, we'll be verifying this formula. Let's take A is equal to 1, B is equal to 2 and C is equal to 3. First one, A plus B whole square is equal to A square plus B square plus 2AB. Right? Or A plus B whole square is equal to A plus B into A plus B. That means A plus B whole square. That means 1 plus 2 whole square is equal to A plus B into A plus B. A square, that is 1. B square, that is 4. 2AB, that is another one, 4. How much is that? 2 plus 1, 3. 3 square is 9. Again, 2 plus 1 is 3. 3 plus 3 into 3 is 9, which is equal to 4. 4, 8 plus 1 is equal to 9. Right? Now this one we are evaluating. A plus B whole cube. A plus B whole cube is equal to A cube plus B cube plus 3AB into A plus B. 2 plus 1, 3. 3 cube is 27. 1, 8, 6 into 3, which is nothing but your 18, and this is nothing but 26, 27, right? So this is also correct. A minus B whole square. A minus B, so 1 minus 2 whole square is equal to A minus B into A minus B. A minus B into a minus b, which is equal to a square plus b square minus 2 into a into b. This is what? Minus 1 square, which means 1. Okay. Minus 1 into minus 1, which means 1. Okay. Over here, 5 minus 4 is equal to 1. Right. So this is how this is important. This value substitution thing is very important for you from the exam point of view, guys. Those of you who have been associated with me from AFCAT times, I have been telling you guys to be unorthodox. The moment you guys become very unorthodox with mathematics paper, you are going to enjoy it. Don't look at these numbers, don't look at all these identities in terms of some random variable. Look at this in terms of some concrete numbers, right? You pick out your pen and paper and you do this one. Let's say this one, we'll do it. A minus b. A minus b, how much? That means we should get minus 1. Okay. A plus b whole square. A plus b whole square. That means 2 plus 1, 3 whole 2 plus 1, 3, 9 minus 4ab. 4ab, 4 into 2, 8 into 1. A minus b. We did not get it. Why so? One moment. We must get it. If we don't get it, then this identity goes on to a toss. But these identities have been given by the greatest of the mathematicians. So it cannot go on to a toss. We must have done some mistake. So let's try and evaluate our own stance. So a minus b is equal to a plus b whole square minus of 4 into a into b. Okay. So a minus b minus of 4ab. Okay. So over here, a minus b, they have understood it. They have this formula. These guys, they have given it with a thought that over here, it is as good as b minus a. This is the absolute value, right? This is the absolute value they are talking about, and that's why we bumped up with that. So a plus b, 2 plus 1, 3 square, that means 9 minus 4ab, 4 into 2, 8, which is equal to your root 1, which is equal to 1. Right? So a minus b, the absolute value of it. The absolute value of it. Right? And not just a minus b. They are not being able to distinguish which one is a and which one is b. By their logic, they are assuming that a is 2 and b is 1. If you assume it this way, a minus b will be a 1, which will be equal to root under b, a plus b whole square is 9, minus 4ab will be 8, which means like this. Okay, that is why a minus b or b minus a in modulus, and which means we are talking about the absolute value. Right, boys? Right? Shall I move?
Yes, sir.
So please go ahead and work out these identities. Do not just remember these random formulas. Pick up some numbers like this. You will enjoy mathematics, boys. Come on. Not just for this examination, for all the examinations in your life to come. Okay. Go slightly unhinged and unorthodox in your approach. Right? I'm not a very big fan of formulae. Even in the examination, I'll sit and derive, because that is more fun and creative for me. Right, trying to move on. This is the board mass rule. We just wanted to talk. Every one of you know it. So let's try to do it. Okay. Let us say 1 plus 2 divided by 6 into 5 bar plus 1 minus 2 into 4 divided by 2. Yes, tell me, what is the answer? What is the answer, boys? So the board mass rule says that V stands for your underlined portion. This one is your underlined portion, right? So we'll do that one first. Write it down. 230 plus Now we'll do the multiplication. Okay. This bracket, inside this bracket we are solving, even in this bracket we are solving this multiplication. So 1 minus 8 divided by 2, right? So 1 plus 2 by 30 plus, which this one will give you how much? Minus 7 divided by 2. Okay. You write it as a big bracket or curly bracket, it's all the same. Okay. So 1 plus 1 by 15 plus minus 7 by 2, or if you just simplify it, we'll get minus 7 by 2 and just solve it. How much is that? 30 plus 2 minus 105. Okay. 32, 105, 73, right? So minus 73. Did I do any mistake, or this is the correct? Okay. So basically the BODMAS rule says that this is going to be the order of priority. This is going to be the order of priority as far as your calculation is concerned. Okay. Cool. Anybody who does not know what is BODMAS, underlined portion first rather than bracket then is the second priority. Of the basic meaning of is nothing but multiplication only, but it will get the next priority. The next priority is division, and then is your multiplication, addition, and lastly your subtraction. Right, guys? Shall we move?
Yes, sir.
Boys, yeah, this is a good one. This is a very good concept that I wanted to discuss over here with you guys today. Okay, so if I have to write this number 10, tell me what are the factors of 10? What are the numbers which divides 10? Tell me guys. If you participate, then we'll wind up the classes, this concept classes soon. Otherwise, just study with me till 12 o'clock if you guys want to. I don't mind. Yes. Tell me, what are the numbers which divides 10? Number 1 divides 10, number 2 divides 10. Does 3 divide? No. Does 4 divide? No. Does 5 divide? Yes. When you reach half of that number, the next number will be the complete number. Okay? Remember it this way. So what are these 4 numbers? These 4 numbers are called your factors, right? And what if I tell you 10? And then I write 20, and then I write 30, and then I write 40, then I write 50, then I write 60. What are these? These are your multiples. Are these a multiple, guys? Are these your multiples?
Yes, sir.
Yes, obviously yes. And what about this 1, 2, 5, 10? These are your factors, right? Now let's take a number. I took this number as 120. Can this number be written as 12 into 10? Or otherwise 2 into 2 into 3 into 2 into 5. Can I write that? Can I write that?
Yes, sir.
Can I write it as like this? Can I write it as like this?
Yes, sir.
So over here, to find the number of factors, okay, if 10 was there, what were the factors? 1, 2, 5 and 10. And 10 can also be written as 2 into 5, right? Over here is 2 raised to the power 1 and 5 raised to the power 1, right? So the number of factors is how much? 4. These are the number of factors. 4, 1, 2, 3, 4. 1, 2, 5, 10. These are the 4 different factors of 10, right? Yes or no?
Yes, sir.
So this is given by a formula called m plus 1 into n minus 1. Okay, where m is the power of your one of the prime numbers and n is the power of another prime number over here. Okay, m or n plus 1. So m is your 1 plus 1 into 1 plus 1, which is essentially it will give you 2 into 2, which is equal to your 4. Right? So Joshua, this is for you. Tell me what is the number of factors for 120? Yes. tell me what is the number of factors of 120? We don't have to do
Sir,
anything.
can you repeat again?
Yeah. What is the number of factors of 120? This is my question. Number of factors. So number of factors, Joshua, look how you will find. Okay. These are the powers. These are the powers in its simplified form. We do nothing but write down that number plus 1, power plus 1, power plus 1, power plus 1. What is the answer? 4 into 2 into 2. How much is that? 16. So Joshua, what will be the number of factors for 120?
16.
16. Yeah, 16. So if you have to write down, the factors are 1, 2, 3, 4, 5, 6. Let me know if I miss someone, okay? 7, no. 8, yes. 9, no. 10, yes. 11, no. 12, 13, 14, 15, 16, 16, 8, 68, 68. No, not even 16, 17, 18, no. 19, 20, 21, 2, 3, 4, 5, no. 30, okay. Then 40, then 60, then 120, right? Did I miss someone? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, we did miss someone over here. Which one did we miss? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is 16 a factor over here? 16 a factor. Is 16 a factor? 8, 60, 34. No, 17, 18. 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, boys, which number did we miss? 24 we missed. Yeah. We missed this number called 24 over here. Okay. So these are the 16 factors, right? 16 factors that we were talking about. Right. So how will you find the number of factors? You will first factorize it in the simplistic form, and then you will do power plus 1 into power plus 1 into power plus 1. Right. Now, if I have to ask you, what is the number of even factors of 120? So in order for this number of factors to be even, you see, when we write 2 raised to the power 3, no, it means what? It has four different 1, 2, 3. This has 4 different instances, right? It has 4 different instances that we can write it like this. 2 cube, 2 raised to the power 3. It has got like 4 different ways of writing it, okay? And when we write 3 raised to the power 1, it has 2 different ways of writing it. Either you write 3 raised to the power 0 or 3 raised to the power 1. 5 raised to the power 1, it has 2 instances of writing, 2 ways of writing, okay? So there are like 4 different ways, 2 different ways, again 2 different ways. So that means 4 into 2 into 2. If you take any combination, let us say I have taken 2 raised to the power 2 and I have taken only 3 raised to the power 0 and 5 raised to the power 1. You take any combination, you will find one of these numbers. How much is that? 4 into, this is 1, this is 5, this is 20. You tell me which combination I should take. Any combination, tell me. I took 2 raised to the power 1 and then I took 3 raised to the power 1 and then took 5 raised to the power 0. So 2 into 3 into 1. How much is that? Is this number here? Yes. Is 20 number here? Yes. This number is here. So if we have to find the even number of factors, guys, if we have to find the even number of factors, there has to be at least there has to be at least one number, this 2 particular number 2 has to be present at least once. Am I clear? Are you guys following me? Say yes or no. The presence of 2 is mandatory in that number. Then only, see how many number of even factors are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So there's like, sorry, over here it is 12. Okay. 12 even factors are there. But if let's say number is huge, let's say 1729, what will you do? 1008. What will you do? Will you count this number of factors? No. So at least number of 2, we cannot have 2 raised to the power 0 instance, right? Except for this instance, all other will work out, right? So there are 4 ways of writing this 2 raised to the power 3, but since it has to be even, that means we'll have to pick up at least 1 2. That means it can have either 1 2, 2 2, or 3 2. That means there are 3 instances only, as against 4 instances that we used to do, power plus 1 that we used to do. Okay, now we'll not do, we'll just only do power into 3. Whether 3 is there or not there, does it even make any difference in the even number of factors? Yes or no? No. So there are 2 ways of writing 3, that is 2. 2 ways of writing 5, again that is 2. How much is that? Tell me, how much is this? How much is this, guys? Look, you guys go back and think about it. Okay? I know. In the first instance, nobody gets it. Even I did not get it. Okay? It's okay. So 12 is the number of even factors. So there will be only 2 instances, either it is even or odd. So if the total number of factors we have found out is 16, so what is the odd number of factors? That is 4. Is that 4, guys? Are you with me? Any one of you, at least. Any one of you, are you guys with me?
Yes, sir.
Cool. Thank you so much. Now if I ask you what are the prime factors? Look, what are the prime factors? The number 2, number 3, number 5. These are the only 3 prime factors. That's it. All others will be composite. All others will be composite. Okay. This number 2, this number 3, and this number 5. That's it. Rest all others are composite. Right? One is neither prime nor composite. So how much is the composite numbers? 16 minus 3 or 4. 3 or 4. 3 or 4, guys. 3 or 4. So 3 is all this prime factor itself. These 3. Number 2, number 3, and number 5. These are the 3 prime factors. Okay. And number 1 is your neither prime nor composite. So this also has to be removed because this is an extra. It's in a special case. So we'll reduce 4. So the answer to this question over here will be how much? How much? 12, right? Right, guys? Anyone? Are you guys following me? Are you guys following me? Anyone who
Sir,
did not follow me?
Please again,
Which one?
that number of composite factors.
Yeah. So number of composite factors. Look, number of composite factors. One moment. This can be written as 2 raised to the power 4, 3. Right? Okay. Right. 120 is equal to 2 cube into 3 into 5. Right now? Yes or no? Who asked me that composite factor?
Yes, sir. Yes, sir.
Yeah. Who is that? Who is that? Your name, buddy? Joshua?
Yes, sir. Yes, sir. It's me.
So these factors, these number 2, 3, and 5, these are the only 3 prime numbers over here. Prime numbers over here.
Yes,
Right.
sir.
Since these 3 are the prime numbers over here, total number of factors are 16. We have already found it. So prime numbers will reduce 3. Minus we'll also have to reduce this 1 as well. We'll also have to reduce this 1, no, because 1 is
Yes, sir. Yes, sir.
neither prime nor odd. So
Nor
that-
composite.
yeah, sorry, neither prime nor composite. Sorry, yeah. So your answer will be 12. Now you got it?
Yes, sir.
Cool. Now let me take a small number, 140. Can we write it as 12 into 2, 12 into 12? Can we write it something like this?
Yes,
So what
sir.
is the number of factors here? What is the number of factors here? 4 power plus 1 into power plus 1, which is nothing but 5 into 3, which is your 15. Okay. 15 is your odd number. 15 is your what number? Odd number, right? So there is a property. The property is called the number of factors of a perfect square. This is what 144 is a perfect square, right? Is what? Is an odd number. You take out any other case of the entire world, you will find the number of factors will be in all other case will be even. Okay, 36, 6 square. Okay, that means 2 square into 3 square, right? That means 3 into 3. How much is that? 9. 9 is your odd number. 48 is not your complete square. Okay, so 48 is 16 into 3. So 2 raised to the power 4 into 3, 48. What is the number of factors here? Power plus 1 into power plus 1. How much is that? 10, which is your even. So far, so good. So far, so good, guys.
Yes, sir.
Is it interesting or is it getting too much of load on your head? Avikaran, how is it?
Yeah, it's getting interesting.
Yeah,
Sir,
yeah.
I have one doubt.
Yes.
For 144, can you tell number of even factors?
For 144 number of even factors, look, 2 raised to the power 4 is there. Okay. If 2 raised to the power 4 is there, that means 2 can be written 2 raised to the power 0, 1, 2, 3, or 4. That is why we write 5, 4 plus 1, 5. Okay. These are the 5 different instances. But in order to make it even, there has to be at least 1, 2 in that number. So this case of 0, 2 raised to the power 0 will not be taken into account, right? Only these 4 instances will be taken into account, right? So that means only 2 raised to the power either 1, either or 2 or 3 or 4, that means 4. And nobody gives a shit to this number called 3 because their presence or absence would not influence the number of even or odd number of factors, right? So we'll just write it as 3. What will be your answer? 12. Okay. What will be the number of odd factors? Just minus 15 minus 12, right? Think about it, Abhikaran. It's a very good brain exercise.
Yeah.
Okay. Think about it.
Understand, sir.
Think about it. I mean, what am I saying is that 2 raised to the power 4, that means 0, 1, 2, 3, 4. Any number of it can happen. 2 raised to the 3 raised to the power 2 means 0, 1, 2. So these 5 instances into these 3 instances, okay, permutation combination. When you multiply 5 into 3, you get 15. This is the number of factors here. But if it has to be 2, if it has to be an even, this possibility of 2 raised to the power 0 has to be chucked out, has to be taken out of the picture. So if we take out this instance from the picture, we'll only be left with 4 other options, that is 0, 1, 2, 3, and 4, right? So these 4 instances into these 3 raised to the power either 0, 1, or 2. So that is 3. That means 12, right? Cool. Got
Yes,
it?
sir, I understand.
Those of you who did not get it, you will get the recording. Okay. So go back, wind it up, and listen to it. Listen to it when your mind is calm. Okay. You will get it. And when you get it, that will be like hell. Like seriously, mathematics is magical. You'll feel that way. So sum of all the factors, there's a formula. Let me go ahead. So this is your formula. Okay. So let's do that for 144 only. 144 is basically your 2 raised to the power 4 and 3 square. Okay, so sum of the formula is given by a raised to the power p plus 1. A is your what? 2. P plus 1, that means 5, minus 1 divided by a minus 1. Okay, a minus 1 is how much? 2 minus 1. Okay, into b. B is how much? Your 3 into q plus 1. 3 minus 1 divided by b minus 1. That means 3 minus 1. How much is that? How much is that, guys? 32 minus 1 into 26 divided by 2. That means 31 into 13. Okay, so the sum of all the factors of 144 will be this 403, right? You go through all of this once at your own end. Okay, and let me know if you find any difficulty. If P divides Q and R, then P also divides their sum and differences also. Pick up some number. If P divides Q and R, that means let's say P, let's take 3. Okay, let's say I'll take 12, and R, let's say I'll take 27. Okay, so what is saying? The P also divides their sum and differences also. So what is their sum? 39. Yeah, 39 is divisible. What is their differences? 27 minus 12, their differences is here 5, 15. Is it divisible by 3? Yes, both of these are divisible. For any natural number, nq minus n is divisible by n. Let's say n is equal to 2. So 2 cube minus 2 is your nothing but 8 minus 2, which is basically your 6. Okay, if 3, you will take 27 minus 3 is equal to a 24, which is still divisible by 6, right? Okay, so similarly, you pick up all of these properties, pick up some number and test it at your own end, right? So with this, I'll end the chapter over here. Abhikaran and Joshua, Mateshwar and Muhilan, thank you so much for joining. And see, there is no breadth of how much of concept that we can actually learn from this chapter called number system. Okay, and number system as a chapter is an ocean, I tell you. Let me be very honest and blunt and honest with you. Okay, but there is a way. As it says, number system, do not think variables as in terms of variables. Think of them as proper numbers, as some random constants. Try to plug in this, try to verify it at your own end and see what happens. Okay, if you guys have any other doubt, same thing we have already studied, number of divisors or the factors, which basically is the same. Okay, p plus 1, q plus 1, r plus 1, right? And lastly, there's like 120 questions. I hope my screen is visible to you, from page number 208 in the soft copy that I have shared with you. Please read and do all these 120 questions. Please try fiddle around all this. Okay, number system, if you know this, if you learn this, this will boost a lot of your confidence. Okay, this is going to build the genesis of your entire mathematics. This is what I can say. Okay, so thank you so much for joining. Good night, sleep tight, and we'll meet again tomorrow. Bye bye, take care.